Show that the relation R in the set A given by this relation is an equivalent relation. So we're looking at a question which we have the destination. We just have to go to it. So we have been given that R is going to pick up ordered pair wherein the modulus of this is even. So where do A and B come from? They come from set A, and set A itself is made up of 1, 2 till 5. Now, so let's start off with the reflexive. We don't have to check it, we just have to prove it. So let's consider a value which belongs to set A. So if I take the difference between A and A, that will result in 1, which is an even number, right? So I have A comma A belonging to R. Agree? Therefore R is reflexive. Next we have symmetric. So we'll start off with let A comma B belonging to R. So in symmetric we need to assume that one of the pair is true, and so the other way around is also true. So from this, what can I tell? If I take the difference between them and take the modulus, it will result in an even number, right? That's the point of taking A and B belonging to R. Now from this, what do I have? From this I have minus 1 times of B minus A. How did I do that? I just happened to take minus 1 common out of A minus B. If you guys are confused, just multiply this. You can see that it is true. So minus 1 into B is minus B, like over here. Next, minus 1 into minus A is A, like over here itself. So basically it is true. So everything is good over there. Now, since we are looking at modulus of a negative number, we know that it will result in positive. So we just prove that A minus B minus A is also even. Therefore, B comma A belong to R. Okay, we'll just write that modulus of any number, any negative number is positive itself. Okay. Now, so with this, what can I tell? From this, I can infer that R is symmetric. Okay, all this is good. Next is transitive. So for transitive, what is that we are looking at? We are looking at let A comma B and B comma C belong to R. So what can I tell from this? Well, from this I can tell that I have this to be even, which I'll further rewrite it as 2m, because in transitive we have to have one more step wherein I'm going to relate the A over here and C from there. For that I need this, and M belongs to Z, right? Similarly, I can rewrite B minus C as, and B minus C will also be even to n, right? So n belongs to an integer. Now we'll consider the first element from the first set from the first order pair, and the last element from the second order pair. So we need to consider this. So I'm going to write this as modulus of A minus C. I'm going to rewrite this as plus 0 in the middle. I can do that, right? And further, I'm going to write 0 as minus B plus B minus C. Do you guys agree? So we have A minus B and B minus C. A minus B is what? 2m. B minus C is what? 2m. And that's the point of adding 0 and all of that. So this is nothing but your 2m plus 2n. So we have 2 times of m plus n, right? So we have, what did we do? We just substituted over here and we took 2 common. So 2 times of any sum will result in, yes, even. That's the whole point, right? So we have over here, this is an even, reason being 2 times of any integer is even. Okay, next. So from this, what can I conclude? From this, I can conclude that a minus c belongs to R. As simple as that. Next, what is that? We have a and a, not a minus c, a comma c belongs to R. Then what do we have? Finally, R is, actually I need to conclude that also. R is, this is transitive, right? Transitive. Therefore, R is equivalent. So this is your first part of your answer. I hope you guys are not confused over here. A minus b, a minus b itself, it's nothing but 2n. B minus c is 2n. So 2m plus 2n, when we take 2 common, it is m plus n. So 2 times of any integer is even. And so that's why this is even. And so a comma c belongs to R. As simple as that, right? But the question is not yet over. So that all the elements of this particular set, so the curious thing about this particular set is, so odd numbers are related to each other and all the elements over here are related to each other. And we also have, okay, it's continuation, but no element of this odd set is related to any element of this even set, right? It's quite simple actually. So we are looking at case when A and B are all odd or both odd. So what happens over here? Therefore, I can write A as 2m plus 1 and B as 2n plus 1. Any odd number can be written in this manner. So where m and n belong to z. Now, the modulus of A minus B would be 2m plus 1 minus of 2n plus 1. So here plus 1 and minus 1 gets cancelled and we have modulus of 2m and 2n. And this is nothing but 2 times of m minus n. And this is nothing but an even number. Right? Now we look at case when A and B are both odd, both even. So what do we have? Therefore, A can be written as 2m, B can be written as 2n, and m and n will belong to integer set, right? And we have modulus of A minus B will be equal to 2m 2n, which is 2 times of m minus n, which is an even number again. We'll take case A as odd and B as even. Therefore, what do we have? A is 2m plus 1 while B is 2n, right? So where m plus 1, where m and n belong to z. Now, what do we have? A minus B will be equal to 2m plus 1 minus 2n. So this is 2 times of m minus n plus 1. So anything that is added to an even number, which is an odd number, that is, if it's an odd number, it will result in odd. So this will result in odd, because even plus odd is odd. So we just prove that, right? So the vice versa can also be proved. Vice versa means the other way around also can be proved similarly. Okay, so we have A to be odd and B to be even. The vice versa means A is even and B is odd. So even then, even with that, it will result in the following. So overall, from the above discussion, what can we conclude? From above discussions, one, three, five are related to each other and not to 2 and 4, right? So here when we took this is 1, 3, 5 are related to each other. From this, what can we conclude? 2 and 4 are related to each other. Therefore are related to each other. While in this case, we can conclude that from the above discussion, these are related to each other and not to 2 and 4. Or we can just, since we already written that statement, if you guys don't want to write it over here, you can always write it at the end from the above discussion. In this case, since I already wrote it, 1, 3, 5 will not be related to 2 and 4. Okay, yes, this is the lengthy version of writing the answer. If there is a shorter version and if your teachers are okay, you can write that. But yeah, I wanted to be technically right, so the answer looks this long. If not, there are shorter versions. If your teachers are okay with that, then you guys can write that. Please approach it that way. But logically, this is how you have to approach technically.